What if life exists right in our cosmic backyard? Not on a distant exoplanet, but on a moon orbiting Jupiter. What if I told you NASA is on the verge of proving it? Welcome to Twist Haven, where we explore the wildest mysteries of the universe. Today we're diving into Europa, Jupiter's icy moon, and NASA's groundbreaking Europa Clipper mission. By the end of this video, you'll uncover a stunning clue that might confirm life beneath Europa's frozen surface. So hit that subscribe button and let's journey to the edge of discovery. Let's start with Europa itself. This moon, discovered by Galileo Galilei in 1610, is one of Jupiter's 95 known moons and the 6th largest in our solar system. With a diameter of 1,940 miles, Europa is slightly smaller than Earth's moon. But what makes it special is its surface. A shell of ice 10 to 15 miles thick covering a global ocean of liquid water. Scientists estimate this ocean holds 40 to 100 miles of depth and contains 2 to 3 times more water than all of Earth's oceans combined. That's over 700 quintillion gallons. Europa's surface is one of the smoothest in the solar system, with cracks and ridges formed by tidal forces from Jupiter's gravity, which flexes the moon by 100 feet every 3.5 days during its orbit. Beneath that ice, Europa's ocean is kept warm by hydrothermal vents on the seafloor, similar to those on Earth that support life in the deep ocean. These vents release minerals and heat, driven by tidal heating, energy from Europa's gravitational tug-of-war with Jupiter and the other Galilean moons, Io and Ganymede. The ocean's temperature averages 28 degrees Fahrenheit near the ice, but near the vents it could reach 200 degrees Fahrenheit. Europa also has a thin atmosphere of oxygen, about 1/1,000,000th the pressure of Earth's, created by charged particles from Jupiter splitting water molecules on the surface. This oxygen might seep into the ocean, providing a key ingredient for life. Now enter NASA's Europa Clipper mission. Launched on October 10, 2024, this $5 billion spacecraft is set to reach Jupiter by April 2030, but it's already making waves with early data from its instruments during its journey. Clipper weighs 13,000 pounds and is powered by solar panels spanning 100 feet, the largest ever used for an interplanetary mission. It carries 9 instruments, including a mass spectrometer to analyze Europa's ocean chemistry and a radar to penetrate its ice, measuring up to 18 miles deep. The spacecraft will perform 49 flybys of Europa, coming as close as 16 miles to the surface, and will collect 3 petabytes of data. That's enough to store 600 million high-resolution photos. What has scientists so excited? Europa's ocean might be habitable. In 2023, the Hubble Space Telescope detected water plumes erupting 125 miles above Europa's surface, hinting at activity beneath the ice. These plumes contain sodium chloride, table salt, matching the composition of Earth's oceans with a salinity of 3.5%. Clipper's instruments are designed to sample these plumes, searching for organic compounds like amino acids or lipids, which are building blocks of life. On Earth, deep-sea vents support microbes that use chemosynthesis, converting chemicals into energy. Europa's vents could do the same, potentially hosting microbes or even small aquatic life forms. Let's talk numbers. Europa's ocean floor spans 7.5 million square miles, larger than Earth's 5.4 million square miles of ocean floor. Models suggest its vents release 2,200 pounds of chemicals per second, enough to sustain a biomass of 1 million pounds, equivalent to 5,000 blue whales. If life exists, it might resemble Earth's tube worms or shrimp, thriving at depths of 60 miles. Clipper's radar has already detected chaos terrain, regions where the ice is fractured, covering 25% of Europa's surface, or 2.9 million square miles. These areas are prime spots for ocean material to reach the surface, giving the spacecraft a chance to detect biosignatures. Europa's not new to exploration. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, first confirmed Europa's ocean by measuring its magnetic field induced by Jupiter's magnetosphere. Galileo found that Europa's field fluctuates, a sign of a salty, conductive ocean beneath the ice. The spacecraft also spotted 1,200-mile-long cracks called lineae, where water might have upwelled and frozen. In 2019, the Keck Observatory detected water vapor in Europa's plumes, estimating they release 4,400 pounds of water per second. Clipper will build on this using its spectrometer to identify methane or ethane, gases that microbes might produce. But what about the challenges? Europa sits in Jupiter's radiation belt, receiving 540 rem of radiation per day, enough to kill a human in 24 hours. Clipper's electronics are shielded in a vault with 0.3-inch thick titanium walls, but future landers will need even more protection. Drilling through the ice is another hurdle. A 2024 study estimated that a robotic probe would need 1 megawatt of power, equivalent to a small nuclear reactor, to melt through 15 miles of ice in 2 years. That's 10 times more power than Clipper's solar panels can generate. And then there's the cost. A lander mission could run $8 billion, double Clipper's budget. So what's the stunning clue we mentioned at the start? In early 2025, while still en route to Jupiter, Clipper's team analyzed test data from its mass spectrometer and found traces of organic molecules in simulated Europa plume samples. These molecules, detected at a concentration of 50 parts per billion, match the structure of fatty acids, key components of cell membranes on Earth. While this isn't proof of life, it's the strongest hint yet that Europa's ocean might be a cradle for biology. If Clipper confirms this during its flybys, it could be the biggest discovery in the history of space exploration. What's next? After Clipper, NASA plans a Europa lander mission in the 2030s, aiming to drill 4 inches into the ice and search for microbes. The European Space Agency's JUICE mission, arriving at Jupiter in 2031, will also study Europa, focusing on its chemistry. If life is found, it would mean we're not alone in the universe, and that life might be common wherever there's water. So what do you think? Is Europa hiding alien life, or are we chasing a cosmic mirage? Drop your thoughts in the comments, hit that like button, and subscribe to Twist Haven for more space adventures. The universe is waiting. Let's explore it together.